Hello and welcome to this presentation. My name is Dave Hideman. I'm the Applications Specialist for the Steel segment here at Trimble. And today I'm going to give you an overview of Tekla Structure's features and functionality, specifically geared towards structural steel detailing and fabrication. So first let's take a look at a small sample project. This is actually a project completed by one of our customers. You can see that it's a pretty good example of different types of steel framing. If I zoom in here, we can see we've got beam and column framing, we've got bracing connections, different types of embeds, stairs and rail, we got roof frames, all kinds of stuff going on in here. Now, everything built in this model is built to a one-to-one scale. So the idea is that you create an as-built of the actual project, and then from this as-built you pull off all of your reports like your material lists, your bolt lists, and then you can create all of your shop details, your framing plans. Everything comes from this completed model. So let's close out of this and I'll show you how you can create a model from scratch. So I'll start by double clicking on my Tekla Structures icon, and what I'll get is this menu where I can choose some options that kind of tailor Tekla to my needs. So first thing I want to choose is an environment. Now I have the US Imperial environment installed, but we have environments from all over the world. The idea with the environment is that you get certain things set up for your region, like all of your AISC steel shapes would be included in this environment. You can also choose from a role. Tekla Structures caters to a lot of different aspects of the industry, so we have things like engineering, cast in place, precast, and rebar. I'll of course be using the steel detailing role for this presentation. And then finally you choose your configuration. Configuration is simply a term for your license type. I have a list of all of the available license types that you could purchase. I'll be using a steel detailing license for this presentation. When you launch Tekla, you will only see a list of the licenses that you actually own. So with those loaded, I'll go ahead and hit OK, and that will launch the software with those settings. Now, as you can see, when I get into the welcome screen, I have tabs for my most recently opened models. I can either go for all models or I can go to the new tab. And on the new tab, I can create a model name. So I'll call this Tekla Structures Overview. And then below you can see that I can choose from different model templates. The idea with a model template is that it sets up Tekla structures for that particular type of work. So here I have the steel detailing model template chosen, so that means I'll get steel specific drawing types that have bills of materials and things like that that I want to see. It's also possible over time for you to create your own model template. So if you do a certain type of work a lot, or maybe you have work that you do for specific customers, often you can create model templates for those, and that way you can hit the ground running with those settings. So with the steel detailing model template chosen, I'll go ahead and click Create. So when Tekla first opens, what you'll see is a 3D view that you can navigate like any other CAD software. If I hold down my mouse wheel, I can pan back and forth. If I scroll my mouse wheel, I can zoom in and out. Or if I hold down the control key, I can rotate around the model to look at it from different angles. You also see that the ribbon commands have loaded. They're broken down into tabs like steel, concrete, view, drawings, and reports, so it's very easy to find the type of command that I'm looking for. I also have a quick launch that if I'm looking for something in particular, I can type in a search phrase like beam, and it will bring up a list of different commands that contain the word beam. Now, the appearance of your ribbon is going to differ depending on what configuration you launch Tekla with. Since I started with a steel detailing role, you can see that the steel tools are very prominent, where the concrete tools are a little bit smaller. If I had started with a concrete license, the reverse would be the case, where the concrete tools would be very prominent. If I'm opening Tekla with a more multi-material license type like primary or full, you'll see that the steel and the concrete tools share about the same size. So if I want to start by creating something like a column, I can open my column properties, and here you can see how we set up what the column is going to be and what it's going to look like. First, we have our numbering settings. Numbering in Tekla is basically our piece marking setup. So with this, our first column would be C1, and then subsequent columns would be C2, C3, and so on. We can change the name, so you can have something called column or post or bollard. You can change the profile. You can either type in what you want, or you can click on the select button to open up our profile catalog. Now the profile catalog is set by the environment that we installed. Because we installed the US Imperial environment, what we have is the 14th edition of the AISC catalog. As you can see, they're broken down by type, so I profiles, then W for wide flange shapes, and then I get down to my nominal depth of W16, and then it's choosing a W16 by 50. If I collapse some of these, you can see how it's broken down into S shapes, joists, K series, and LH series. I've got angles, T's, channels. Again, I just drill down to get to the size and shape of what I'm looking for. All of the shapes you would expect to find you can find in here. Light gauge profiles, HSS members, and it's even possible to create your own custom shapes. As an example, what we've done is we've imported some DXF files of ornamental pickets from Julius Bloom just to show that it's possible to get custom shapes of any type into Tekla structures. These can be brought in like these were using a DXF file. They can also just be sketched out into the model to create the cross section. So there's many ways to customize the profile catalog for whatever types of shapes you might need. Let me go ahead and choose a column size. Next, I can choose a material grade. Just like the profile, I can either type in what I want or I can hit the select button to choose a grade that's available in the catalog. So all of your standard grades are going to be here, your A992, A572, A500, A36, all that stuff. Also, if I collapse steel, you can see I've got concrete, rebar, timber grades, miscellaneous grades such as aluminum, drywall, glass, neoprene. Again, totally customizable. So if there's a material grade that you need to use, so like maybe fiberglass or stainless steel, and you can add it into our catalog very easily. And of course, the material grade sets the weight of the member. So if I make something like an angle out of steel, and then I make another angle the exact same size and shape out of aluminum, the aluminum shape will naturally weigh less. So Tekla Structures is keeping track of all of those things for you. Now if I go to the position tab here, I can set the top and bottom elevations. Now this is again a one-to-one representation of my model. So this would be actual top of steel and actual bottom of column or bottom of base plate. So I'll just leave the defaults, and what I can do then is aim at my grid, and as you can see there are snap icons just like any other CAD software. So I've got midpoint snaps, endpoint snaps. Down here on the bottom you can see my snap toolbar, so I can turn on snap to centers, midpoints, intersection points. So it's all very familiar to what you might be using now. Now when I aim at an intersection and I click to create my shape, you can see with a single click I get a 3D solid. If I zoom in, there's no processing required, there's no extra work, I simply get a 3D shape. And then everything I need to know about this 3D shape is instantly available. If I inquire on this column, I can tell you how much it weighs, I can tell you surface area, I can tell you checking dimensions, center of gravity. All of that stuff is instantly available. Now if I want to interact with the shape, I can simply click on it and then change something like the height. Or I can turn on those same drag and drop tools using direct modification to simply stretch the column shorter or stretch the column taller. Another tool that's available is this contextual toolbar. Now as you select different objects, the toolbar will change to reflect the properties of that item. So here it's showing me that this is a column, it's a 16 by 89, and its top is at 23 feet. There's also additional tools like this position flyout, so I can spin and adjust the rotation of this column very easily. So as you can see, there's many ways that you can interact with shapes in the model. So I'll set that back to 20 feet. And now when I start creating more columns, they're all going to take the same shape and height as the original. Now what I'm going to do here is create a small platform and then frame a stair up to it. So let me take these two columns and I'll change their size and shape. Now you may have noticed in the column properties dialog we have this save, load, and save as. It's pretty standard across Tekla structures to see those buttons. The idea is that you can save away repetitive things so that you can quickly load them and use them again later in the model. So here I have an example of a saved away HSS column. I'll click load. You can see how it changes the profile, it changes the material grade for me, and then I can simply modify those two parts. So as you're working, whether it's creating parts like this or creating connections or drawings or anything like that, think about what you might want to save for future use. Now these items get saved into this model, but it's also possible to save these into what we call a firm folder so that they're accessible to everybody working either in your project or everybody working throughout your company. Now again, Tekla is fully multi-material, so if I wanted to create some pad footings, I can use my footing tool. Again, I'm going to use a preset that I have to basically set up the top and bottom elevation of this pad footing. Now it's not necessary to create concrete like a pad footing for embedded items like anchor rods or embed plates or something like that. But if I want it to be shown on a drawing, I need to have it in the model because our drawings are simply representations of model space. Next, I might want to come in and start creating my base plate details. Now I've got tools back on my steel tab where I can load up a plate, I could create my plate, I could use the bolt tool to create anchors, I can weld these parts together. But rather than do that, we have parametric tools that group together these parts and make them smart. So they'll actually read what you're applying them to and adjust their size automatically. Those tools can be found under the Applications and Components side pane. So here you can see that they're broken down into different groups. I have a personal favorites group set up, but you can also find them for macros, steel detailing components. If I expand this, you can see that the steel detailing components are broken down into little subgroups like beam to column, bracing. This applications and components side pane is also searchable. So if I'm searching for something like a base plate, I can simply type in the word base, and I get all of the options that pop up that have the word base in them. A quick example that I want to show you, even though it's not necessarily steel detailing related, is a great example of how the parametrics work in Tekla. So I'll do a search for the word pad. I'll show hidden items so that we can see some concrete components. I have this pad footing reinforcement. So the pad footing reinforcement, if I quickly apply it to this pad footing, is going to read the size and shape of the footing and then create the bars inside of it automatically. Now the reason I'm bringing this in is to show you how if the pad footing size should change, the number of bars and the spacing of the bars will adjust automatically. If I change the depth, the size will change in that direction as well. So that's a great example of parametrics in the model, and these same parametrics are going to apply whether it's a concrete item or whether it's beam to beam framing. It'll read the size and shape, the orientation of the parts, and will automatically match those framing situations. So let me go back and I'll search for my base plate again. As you can see, I get different base plate types like square base plate. I get the bottom of stair stringers. I got some handrail post plates, and if I scroll down further, let me hide those concrete related items again. You can see that there is a base plate 1047. This happens to be my favorite because it's a very robust component. It can do just about anything I need it to do. So I'll rotate my model into an elevation, and just in the interest of saving time, I'll apply this to all the columns at the same time. So I'll pick at the bottom of one column, and what it's going to do is it's going to look at that column size and shape, and it's going to automatically build a plate that will work. So here you can see, even though there are two completely different column sizes, and I didn't tell it how big the plate should be, Tekla tried to come up with something that would work. Now I could come in here and I can double click on this and customize it to be whatever I want. So if I wanted to make an 1.5 inch plate, maybe 20 inches, by 20 inches. I click modify, and now that plate has changed its size and shape. You'll notice that our dialog boxes are very graphical, so I can come in here and I can simply go through the tabs that I can look at the images of what I'm trying to do and enter the values that I want. Great example of this is if I go to the anchor rods tab, I can simply choose from drop-down menus to select a straight anchor instead of a bent anchor. I can turn on different objects, like perhaps I want to include a nut and a plate washer at the bottom. So I'll tell it to include those. And then I can modify, and we'll see that reflected here in the model. This is a great opportunity for me to come up here and save this away as base detail A. So now if I have this same size column that I want to apply this base plate detail to, I can simply load it from the drop-down menu, and I don't have to worry about setting up that configuration again. Now in Tekla Structures, even our welds are solids. You can see the weld path created here around the column. If I switch my selection so that I can grab just that weld, I can tell you everything about this weld that you need to know just like I could about the column. So if I inquire on it, I can tell you things like the length. I can tell you the volume. We have customers who are taking this weld information and they're able to create weld reports to calculate how much time or cost for shop welding or field welding. Now, because our welds are solids, they can also interact with other model solids. So just as an example, if I change this 1/4 inch all-around weld to be a bevel weld, 45-degree prep, and I'll tell it to be created on one edge only, it will actually remove material from the column flange automatically. Let me go ahead and change my visual settings here so we can get a better idea of what this is doing. So there you can see how it's actually removing material from the flange. And this of course will be translated down to everything else in Tekla, whether I'm creating a shop detail of this column shaft or whether I'm creating CNC files of this member, this data is going to be there. So now that I've created some columns and I've created some base plates, one of the first things I might need to create then is my anchor bolt plan. Now because everything is based from the model, I needed to get a good set of views to create my plans from. So I'll use my grid that I had set up. I'll right click on it and say create view along the grid lines, and it will automatically create every plan and elevation view along those grids. I'll open up my plan at elevation 0, and you can see how I can open up multiple views to see this model from different angles at the same time. You can actually have up to 9 views open at the same time looking at this project. So now that I've got a plan at elevation 0, I'll click in that view and I'll simply say create me a general arrangement drawing, and I'm going to use some out-of-the-box settings called anchor plan with details. We do try to give you plenty of out-of-the-box settings to get you started, but of course you can customize them and save them away as your own standards. So I'll hit create, and what it's going to do is going to find every column with a base plate on it, and it's going to create a blow-up detail at the bottom based on those drawing settings. So here we can see how it's created a main view. There are blow-up details at each column. It's created dimensions between the grid lines. I've got marks being called out. I have 3 separate details because it recognized that I have 3 separate configurations. One for the standard wide flange, one for the HSS, and one for the wide flange that I had modified. All of them are automatically dimensioned out. And these are actual windows into model space. If I take this column and I right click on it and I inquire, I can tell you all the same things about this column that I could tell you if I were in the model. I can tell you how much it weighs, surface area, etc. So what I'm looking at is not a sketch, it's not a representation of that column. I'm literally looking at that column. Now because these are windows looking directly into the model space, that means if I need to cut a section or create another view, I can do it right here from this window. I don't need to jump back into the model to create another drawing view. So I'll go up to my views menu. I'll go ahead and load up some properties. Got one here specifically called AB projection. This is an out-of-the-box setting. And I'll go ahead and I'll cut a section along that grid line and then define its depth. Now when I click to create this, you can see how it's giving me my elevation view of this column. Now this window can be stretched and adjusted, so if I need to see more or less of this column, it's very easy for me to simply tweak this to get what I want. And if I zoom in, we can see it's actually that column I was changing the weld prep on earlier. So this is again a window looking into the model. This is not just a sketch of a column. One of the things that makes Tekla Structures very fast as far as drawing cleanup is if I need to add anything else, like perhaps some custom dimensioning, I don't need to be worried about things like dimension scale. It knows what the distance is in the model and will simply reflect it here on the drawings. So if I pick 2 points between a grid, it knows that that's 15 feet. And the same command, if I come down here and dimension the depth of this anchor rod, it knows that it's 1 foot 1 3/4. So there's no worrying about changing any types of settings. It simply is what it is, and if it's correct in the model, it will be correct here on the drawings. I can add different types of annotations to my dimensions, and I can even group dimension lines. So all of the regular drawing scrubbing commands are very familiar to anyone who's used CAD software in the past. Now it's also possible for me to add different types of annotations like text. Now one of the things that's great about Tekla and text is I can use simple text where I just type in what I want. just like any other CAD software, but we also have a special type of mark called an associative note. Now, an associative note is a live piece of text that literally reads whatever I'm pointing at and gives me information about that part. So here we can see it's a 16 by 89. Now you may notice how the mark has a question mark on it. The question mark indicates that I have not yet updated my piece marks in this model. Tekla Structures is going to keep track of piece marks for me. It's going to find parts that are combined, it's going to break up combinations as the model changes. But since I haven't applied piece marks yet, it's telling me here by using a question mark that I need to do so. That question mark is going to pop up anytime that I have a piece that is no longer up to date. I will show you how to do that in just a moment, but first, let's take a look at the properties in this associative note. So you can see how it's built like a template. It's not just raw text. I'm simply telling it, give me the assembly position, give me the profile or the shape. So if I want to add another bit of information, maybe I want to add something like material grade. So I'll choose material grade, I'll change maybe the color just to make it pop. And you can see that it knows that it's an A992 column. Now, if I use this same associative note on a different object, like an anchor rod, you can see how it reflects the accurate information from that anchor rod. If I even apply it to something like a pad footing, it'll give me information about that pad footing. So rather than having 100 different texts that have been manually typed out, what I can create is a handful of these smart texts or associative notes, and then just use them all around the model. So let's take care of those piece marks and get them up to date. So I'll close out of the drawing quickly. I'll go back to the model space, and updating my piece marks is very quick. I can go to Drawings and Reports, perform numbering, and number any modified objects. So if I go back to my drawing list to take a look at what happens, you'll see that the drawing is going to reflect those changes automatically. If I zoom in, you can see that the automatically created marks have all been updated to show for AB1 or AB2. My manually created marks have also been updated, but then they've also been clouded with change symbols. Now these change symbols don't print by default, they're just there to let the modeler and detailer know that something has changed. If I need to create a cloud, I can do so for purposes like revisions. And once I'm done reviewing this drawing, what I can do is remove those change symbols, and then I can close and save out of this drawing. Now that I'm back in the model, I'll go ahead and open up a plan view at 10 feet, and I'll start creating some of my platform framing. So I'll go to my steel tab, I'll open up my beam properties, and I'll just load standard beam settings. Notice in the drop-down menu there are a lot of out-of-the-box settings: angle, beam, channel, brace. The idea is that you can load these so that you get some things preset that you might otherwise forget, like changing the material grade or changing your numbering series. So I'll go ahead and I'll load beam, and then I'll simply start picking points to create it in the model. You can see that it's as simple as drawing a line, but then I get the benefit of a 3D shape. I'm simply picking 2 points like drawing anything in CAD. I also have pretty standard commands like copy, so I can use copy to create repetitive shapes. And if I want to change the size, I can do so here. I'll make it a horizontal brace. And everything that I'm doing, because I'm working in this plan at 10 feet, is going to happen at 10 feet. Now if I zoom in here, you can see that even this brace is being created at the 10-foot elevation, which perhaps isn't desired. Sometimes you need to drop a member a little bit, maybe for bracing like this, or for joist bearing elevation beams. So what you could do is simply use a move command, but there is another way. If I highlight this part and go to the position tab, I have this option for at depth, where I can simply tell it how far to drop out of the plane from top of steel. Now, one of the benefits of doing it this way is so that all of the parts now share the same top handle. And where that really comes into play is for long-term changes to the model. So if something happens like an elevation change, which happens all the time, I can come in here, I can modify my grid, and because all of those handles are sharing the same location, changes are going to affect all of those parts. And you can see how when the elevation changes, the brace follows the beam. So while it's not necessarily incorrect to move something down, there are ways that you can model that will definitely help in the long-term project if any changes occur. So I'll go back and start making some more framing. I'll load in a channel. And as you can see, it's pretty simple to just make some shapes. Now all the picking I'm doing so far is all midpoint and endpoint snaps, and we all know that buildings aren't always that simple. So if I need to create something that isn't necessarily on an endpoint or a midpoint, but I have a known location, what I can do is set a reference at that known location by holding down the control key and clicking at that point, and then I can simply aim the offset direction and type in how far I want it to offset. And then when I pick my points, now I get a member that's exactly that distance away from a known line. So this makes it very easy to get everything exactly where I want it to be. So let me close that, and I'll go now to an elevation view. And I can create things using the same beam tool like a vertical brace. Now all the modeling I'm doing so far is basically what you would do if you had a set of designs in front of you where you were simply reading off the plans and then modeling in what you saw on the paper. However, if you're getting electronic formats, which most of you likely are, you can insert those into the model space so that you can then trace those documents. So whether you're getting PDFs, DWG files, we can probably import them here into Tekla. So if I go now to my reference model side pane, I'll show you an example of inserting a DXF file. I'll click Add Model, and here you can set things like the scale, the orientation, point to the specific file that you're trying to import. Let me change my work plane so that I can tell it to insert in this elevation. I have a preset for the scale, but we also have tools available to help you find the scale when you're importing drawings. And then I'll simply choose my drawing that I want to import. So as you can see, it's taken that DXF file and laid it in on top of that grid line A. So let me take this and I'll go ahead and I'll line it up with my grid system. And from an estimating standpoint, you can imagine how easy this makes that process. So I'll go back to my steel tool, make sure that I have the right size loaded up here. I'm going to need a C8 by 11.5. And we have a special type of snap in Tekla called snap to line. And as you can see, when I hover over a line, I get this arrow indicating a direction. That allows me to create a part with a single click for the full length of that line. So you can imagine how fast that makes something like creating an estimate model. So I'll just simply click the points and I get my shapes. Now if I want to check my work, I can double click in the background and I have different types of display settings where I can show things like the current profile or shape. And when I do that, I have now a check between what the design called for and what I'm actually creating in the model. Now you're not just limited to 2D references. You can also insert different types of 3D references. So an example of that would be a 3D DWG or DXF. So if I bring in an example here, you can insert something like perhaps mechanical or HVAC, and then you can make sure that your framing is going to clear the ductwork or other mechanical units that are going to be placed. Just like the 2D, I can come in here, go ahead and reset my work plane, and I can create parts by snapping to that 3D reference. Now, the ultimate evolution of this whole inserting a reference model process is getting a source model in a file type called IFC. IFC stands for Industry Foundation Classes, and what it is a universal language across 3D modeling softwares that allows you to interact with other people in the project team who may be using another type of software. So this example is of a small piece of framing. This can come from a design software or another detailing package, but then this solid reference can be taken a step further. Because this is a smart type of file, I have the ability in Tekla to convert these objects into native Tekla parts with a single click. So it's going to go and it's going to find and recognize what those shapes are, and then automatically convert them into native Tekla shapes. So if I hide that, now you can see how I have native Tekla parts that I can use just like any other parts. I can connect to them, I can create CNC files and drawings. So this makes a very fast and very smooth workflow between the design and detailing teams. Of course, in Tekla Structures, it's also easy to model curved, swept, or bent members. If I zoom in, let me adjust some of my snaps, and go to my Steel tab, you can see I have things like the Curved Beam tool, which essentially allows me to pick 3 points, and it will create a swept member. I can also model in a normal straight member, and then simply go to its Position tab, and I can give it a radius, number of segments, and create a curved member that way. By going to the Position tab, I can also change how this part is curved, so I can make it curved in the Z as well as swept horizontally. I can also create bent parts using a tool called Polybeam. So if I bring up a plate profile, let's say I want to make a pour stop, I can set the maximum length of my bending equipment, and then I can simply model in a shape. Of course, there are tools to do things like this much faster, but it's good to know that these can be done freehand as well. Now that I've got what I would call a stick model, this is a great time to start getting some material lists out of this project. So if I go to my Drawings and Reports menu, under my Reports button, we get a lot of reports out of the box that are provided for different things like quantities, details about bolts, welds, drawings, and so on. I've moved a couple of them up to the top here, but these are out-of-the-box reports, such as the material list. So if I click Create from All, it will scan through the model, and it will find all of the different parts, group them based on their size or their profile, give me a total length and total weight, and then all the way down at the bottom will give me a project weight. Now this is an HTML file, but we can also create things like Excel spreadsheets or simple text documents. Another method that we have to group and get information out of the model is through a tool called the organizer. What the organizer does is it scans through the model and it will group items based on their type into different categories. So categories are set up out of the box to be based on things like name, but it's also possible to create your own categories, either based on filters or even based on building areas. So here you can see that I've got things like anchor rods, beams, and channels broken down by their name. I can change my settings so that it can actually highlight those objects in the model so that I can see them. And as I click on the different object types, you can see how it illuminates them in the model and also updates this quick report on the left. So this quick report can either be organized based on every single unique item, to group or combine based on different things, so I can tell it to combine identical rows. And then this quick report, if I do something like all of the steel assemblies, I can export this out to Excel. So as you can see, there's many ways to get this information out of the model into a usable format, even for people who don't have Tekla on your team. Now, one of the other things that's extremely popular from an estimating and a bidding standpoint is the ability to share the actual 3D model. Now there's many ways you can do this. One of them that's very popular is through exporting a 3D PDF. So this is a tool that's not built into the software, but it's what's called an extension. A Tekla extension is kind of like an app that's available for download from the Tekla warehouse, and you can use it to add on to the program to give it features and functions that it couldn't do before, or to help speed up some different workflows. So this one is available for download as part of your Tekla maintenance. It's called Publish to 3D PDF. And if I run it, I have the option to do either selected part of the model or all objects. I can create a simple Acrobat file, or I can also create a U3D file, which is a Bluebeam specific format. So I'll go ahead and say create from all and click Publish. and it will find all the parts in the model and simply export them to a 3D PDF. Now, one of the great things about a 3D PDF is there's no special software required to view it. All you need is regular Adobe Acrobat, which is pretty much what most people have on their computers. You could also share the model using our free Tekla BIM site software. So now I'm at a point where I could start creating some connections in the model. Now I could simply model them in using my steel tools, so I could create an angle, I could create cuts to shorten members, I can create my own bolt groups and weld parts together. But of course there's a better way to do that. I already talked about components for our base plates, so I can use components to make beam to beam and beam to column connections as well. So if I go to my Applications and Components side pane, you can see how it's broken down into different groups. I'll go down to my steel detailing, beam to column connections, and I'll use a clip angle 141. The idea when you're inserting Tekla connections is to use your primary part or your supporting member first, and then the member being supported. So what it will do is we'll look at those framing situations and it will generate a component based on that. So here you can see it's created a cut that shortened the beam, it created clip angles, it created a bolt group, we can see the weld on the back side. So I can just go through and very quickly apply the different types of connections that I want. If I wanted to do something like a bracing connection, so you can see in the model that there's a slight color difference between my bolts. I have tan bolts and red bolts. This is giving me a visual indicator on shop versus field bolts. So if I need to get a report of these shop and field bolts, I can go to my Drawings and Reports menu, go to my Reports, and if I highlight this portion, I can go ahead and create a bolt list. So here you can see how it's going to show me my shop bolts, my field bolts, and my total bolts. So it'd be very easy for me to come through and start filling in the rest of these connections. If I wanted to keep putting my bracing connections, I can do so. If I wanted to go back to my groups and go to beam connections, I could find a two-sided clip angle. It's also possible for me to use the regular components to do things that may not be immediately clear from the images. So if you need to create something like a safety connection, I can double click on my clip angle here, and I can go to my Parts tab, and there are options in here to create safety connections. And then of course what I can do is save these settings away so that I can very quickly load and reuse them later. Of course, any settings that I had set will be reapplied when I pick new parts. Now there is a faster way for me to go ahead and create these different types of connections in the model. We do have a tool called Auto Connection, and what Auto Connection does is it's basically taking some rules. Rules like what type of framing condition am I dealing with? What's the size of the shapes that are framing into each other? And it will automatically scan through and based on those rules find the correct connections and apply them throughout the model. So I'll come back here and I'll sweep my main building and I'll open Auto Connection. And what Auto Connection is going to give me is an option to choose a rule group for what type of connection should be created and then how those connections should be handled. So if I click the drop down menu, you can see we give you some out-of-the-box options such as clip angle standards, shear tab standards, and then fittings and prelim material. Fittings and prelim material is great for those early material lists because all they do is simply provide a cut back to the face of the supporting member so you can get more accurate lengths in your initial material lists. I'm going to use the shear tab connections and settings and then click create connections. So what it's going to do is find those colliding objects of the highlighted members and automatically create connections based on those rules. So if I zoom in, you can see that some of the connection cones are green. Green is good, means that everything fit up. We have some connection cones that are yellow. Yellow means that there's a possible edge distance problem that could require some review. There can also be a red cone. A red cone usually means that something went wrong, like you used the wrong connection in the wrong type of area. If I zoom in on one of these yellow cones, you can see that the issue is that there was a cut and chip required of the bottom flange to allow for that second bolt. Now I can see that because it provided the web extension plate, this would be okay. So as a detailer, I could go ahead and ignore this, but it's always good to review those yellow cones to make sure that it's okay. Now I could also use these components to go ahead and make things like stair and handrail framing. Now I could use my beam tool and I could model in the stringers manually, but if I go back to my applications and components, I do have an entire group from miscellaneous detailing. Under miscellaneous detailing, I have stairs. If I stretch this a little bit wider, we can fit some more icons in here. You can see how I've got different base condition details. I've got different types of treads. If I scroll down, I've got different types of stairs, ship ladders. So if I come down here, I have a Z-pan stair. And if I double click on the Z-pan stair, we can get an idea of how this is going to work. So what it's expecting from me is my bottom nosing and my top nosing. And then I have options for how the bottom of the stair should be framed or how the top of the stair should be framed. If I go ahead and load an out-of-the-box setting called Stair All this is going to do is make sure that it gets welded together in the shop as a unit. So I'll just use those out-of-the-box settings, and I'll pick just a generic nosing point at the bottom, a nosing point at the top, and I'll come off about a foot. So what it's doing is it's looking at those 2 points that I picked, and then it's automatically calculating the number of steps required to make that stair. If I look back at the main dialog box, you can see that there's this 7-inch dimension here for my maximum riser height. So what it's going to do is it's going to calculate out however many are required. It will not go over 7 inches. So I could have a spacing of 6 and 15/16 or 6 and 7/8 or something like that. It just won't go over 7. Now because this stair is still an intelligent component, I can tweak this and adjust it if I need to. So if I realize perhaps that I picked a bottom nosing that was too far out and it's going to interfere with a wall or some other framing, I can grab that bottom handle and I can pull it in. And when I adjust that handle, it will recalculate all of the things about this stair. The same thing can be true for the top. So here I realize that I put my nosing point at top of steel, so I forgot to account for things like concrete and deck. So I'll grab my top handle and I'll move it up. So I'll move it up by 4 inches to allow for that concrete and deck, and again it's going to recalculate the stair and adjust it based on these new picking points. Now I could have used the option inside of the stair component to automatically frame to this landing beam, but I tend to like to have a little more control. Now these parts, these stringer pieces, they're still just regular beams. Even though I'm technically inside of a component right now, I can still interact with them on an individual basis. So that means I can use our regular beam-to-beam connections if I want to connect this thing up to a landing. So I'll use a 146 shear tab and I'll just pick 2 parts. And you can see how it's gone ahead and created that connection for me. Now I could also use one of our stair-specific components. So if I go back to my stairs section, you can see I've got these stringer top connections that'll simply notch the stringer out to bear on the beam. So if I wanted to go ahead and create some base details, those are also in here. So I'll scroll up. I'll create a small closure plate detail using this stairs 1038, where I essentially pick the stringer and then pick the nosing point, and it will finish off the bottom of the stair stringer for me. Now if I wanted to create handrails, there's multiple ways I could do that. Let me go ahead and I'll collapse down the stairs section and I'll go to handrails. So under handrails, I have different types of handrails connections depending on whether I'm using pipe or industrial angle or panels or anything like that. In its most basic form, I can put this handrail in sections. So first I'll insert my posts or my stanchions. I'll use an out-of-the-box setting called posts up stringer. And essentially what this does is allows me to pick 2 points and then indicate which parts these posts are going to be bearing on. Now, if I wanted to, I can change how they're connecting to this stringer. Right now, they're just being cut at a bevel, but I could come in here to the parameters tab and I can adjust with some out-of-the-box settings like creating a base plate on here. So I'll choose a base plate and I get a simple base plate detail. If I had made these so that they offset to the side, I could also use an angle or a shear tab or something like that that would connect to the side of the stringer. I'll just leave it as a simple bevel cut. So now I can create the railing that connects between these. So I'll double click on my railings component. And again, we give you a lot of presets out of the box. I do have some custom ones saved up above, but I can use an out of the box setting like picket rails. Let's see here. I'll do picket rails up stringer with bottom return. So I'll load those settings. And the idea behind all of these out of the box settings for things like stairs is that you can use one of them to get you close to what you wanted. Now that I've put in this rail with pickets, maybe I want to make some simple adjustments. So I'll go to the properties window, and maybe I want to change things like the spacing of the pickets. So I'll go to my vertical rails. Right now it's doing 4 inches exact center to center, but maybe I want to do a equal between faces. That'll be my clear opening. So 4-inch maximum clear opening, which is pretty standard. But some people maybe don't want to use a round picket. Maybe they want to use a square picket. So I can come in here to my middle rails, and right now it's calling for a 3/4 inch diameter rod. And maybe I simply want to call out something like a bar 1/2 by 1/2. So now you can see that it's using a square bar. So again, you can just keep adjusting these settings to get what you're looking for, and then you can come up here and you can save this away as your standard rail. Now there are faster ways that you can insert rail. Once you have your standard post type and your standard rail type saved away, maybe your standard grab rail and kick plates and things like that, you can use this tool which groups these together and inserts them all at once. So I do have some presets just to show how that works. Maybe I want to do something like an industrial angle preset, so I'll load that up. And it works in very much the same way. I'll pick 2 points to indicate my run. I'll pick the beam that it's going to be connecting to and middle mouse click. And you can see how it creates all of those parts at once. So this tool is exceptional for creating long, straight sections of rail very, very quickly. Of course, it is possible to also use my regular beam, curved beam, poly beam tools to freehand model any type of custom rail that I like. So you're not locked into just using the components. So now that I've got some parts modeled in here, I've got connections, I've got some simple miscellaneous framing, now maybe it's time to make some shop details. So there's a couple of ways I can do this, but the first thing that's important is that I need to make sure that my piece marks are up to date. Tekla will not allow me to create drawings unless all of my piece marks are up to date. So I'll go to Drawings and Reports, Perform Numbering, and I will number my modified objects, which gets them all up to date. And again, it's going to find combined parts and put them together. It's going to find combinations that perhaps are broken up now because of these connections that have been added. So Tekla's keeping track of all the piece marking for me behind the scenes. Now the fastest and easiest way to make drawings is to click here on Create Drawings, and this opens up the Master Drawing Catalog. Now the Master Drawing Catalog can be broken down into sections like General Arrangement or Framing Plans, Assembly Drawings, Single Part Drawings, and so on. So if I go to Single Part Drawings, you can see that there's a thumbnail for each drawing type. Now I can bring up a preview of these if I like to see what a basic, in this example, a basic beam drawing would look like. But I can also use those thumbnails to simply load settings. So I'll highlight beam with BOM, I'll choose this beam, and I'll say create drawings. So now I've got a shop detail of this beam created. I can do the same thing for this column. I'll highlight a column, I'll find my column with BOM settings, and I'll hit create drawings. Now what I'm showing you is simple 11 by 17 sheets that have one part per sheet. Now we can also create the 24 by 36 sheets with many beams and columns on them. It's just a slightly different workflow. Now if I'm in a hurry and I just want to create all of my drawings at once, what I can do is I can highlight many different parts, or I could just say create from the whole model. But in the interest of time, let me just highlight a handful of pieces here. And I can come to one of these icons or one of these thumbnails that has a red star. And what this is called is a rule set. And a rule set automatically creates drawings based on rules. So what it will do is it will identify a beam and use beam drawing settings for it. It will identify a column and use column drawing settings, a brace and use brace drawing settings. And it will do this for me automatically. So this allows me to create a lot of drawings very quickly. You can see down in the bottom left there are 9 drawings created successfully. So let me reopen my drawing list. Now, in a real project, you might be dealing with hundreds of sheets for all of the different assemblies or parts on the model. Well, in Tekla, there is a constant link between the model and the drawings, if you remember, because drawings are just windows into model space. Our drawings are not separate things that can get lost or misplaced or be out of date at any point. So, if I want to find which beam is B1, I can simply highlight that beam in the drawing list and click Select Objects, and it will highlight it in the model for me. On the flip side of that, if I don't know which drawing this column appears on, I can highlight that column in the model, click By Parts, and it will restrict the drawing list to show me only drawings that this column appears on. So it's very easy for me to go back and forth and find a specific drawing for a specific part. There's also many other filters and things I can use to find different drawings based on their status, such as up to date, out of date, based on their type, and more. So if I go ahead and I open up one of these drawings just to see what we've got, I'll open up that simple beam. And you can see, although this is a relatively simple beam sheet, how it has gone and created my details, it's cut sections, it's applied dimensions, my build material has been automatically populated, and all of these things happened by activating a single command. Now these are still just views into model space, so again, if I inquire on this beam, all of the information about this beam is readily available. I can also take these views and I can move them around. So if I find that I want to have more room on a sheet, I can simply grab the border and slide them to a new location. All of the regular drafting and scrubbing tools that I would want are here, so if I needed to, for some reason, add some more dimensioning, I can go ahead and do that. Now again, take note how Tekla simply knows what that distance is, so there's no worrying about scaling. There's no worrying about breaking out your calculator and taking off your setbacks and making sure that this is correct. If it's right in the model, if the beam location is correct in the model, then the drawing will simply reflect what's there. So it makes drawing cleanup very, very fast and very, very easy. I can even highlight a dimension string like this and simply click Add Point, and I can just click on New Points and it will just go ahead and keep building this dimension string for me. So again, very easy to add new dimensions if for some reason I didn't like the out-of-the-box dimensions that were given. Now, if I double click in the drawing background, there are a lot of ways that you can customize these sheets. So don't think that what you see here is necessarily the only option you have. Inside of the assembly drawing properties, I can adjust things like what is the appearance of these dimensions, things like font, arrow types, and more. I can adjust how parts are dimensioned. Are we going to provide centerline dimensions, or what we call checking dimensions? So you can customize through the drawing properties exactly what you want your standards to be. And again, you come up here and you save those away so that when you go to create your beam drawing or column drawing next time, it will use your settings. So Tekla is very customizable to get exactly the type of look you want. Now let's say that I wanted to do just a little bit more scrubbing on here. So let's say that I wanted to add some simple text notes, that there's no paint on the top flange. So I'll come in here and this is just simple text, so I'll say no paint, top flange, and I'll modify that text. I can also do something like create a quick detail of a part. So if I wanted to detail out this plate on this assembly drawing rather than creating a separate 8.5 by 11 sheet, I can simply select this plate, right click on it, and say create single part views, and Tekla will go ahead and create a fully dimensioned view of that plate for fabrication. I can also insert simple 2D references. So if you have a library of 2D CAD files that you've been using for things like typical details, maybe a typical joist reinforcement detail for a framing plan, or perhaps a typical weld prep detail for something like this beam, you can still use those in Tekla. If I come over here and click on this 2D library side pane, it opens up this list of 2D details that I can insert very quickly into the model. And the idea is that you can simply choose one of these typical details, and click it into the drawing like a rubber stamp. Now, of course, this isn't going to be tied back to the model in any way, but a typical detail usually doesn't have to be. So it is possible, again, to reuse a lot of the work that you already have, or in Tekla, you can save a detail away as a typical detail so that you don't have to keep recreating that and redimensioning it over and over again. So there's many ways that you can interact with these drawings. Now, what really sets Tekla apart is how we handle changes in the model. So let's take a look at how that affects this drawing. So I'll close and I'll save this drawing, and I'll go back to the model. And let's say that this AC unit that I had inserted earlier be redesigned, which calls for a heavier unit, so that this framing needs to be redesigned to handle that heavier load. So let's say that I have something simple here, like I want to increase the number of bolts on this connection. So say that gets 5 bolts instead of 4. Maybe this channel size is going to increase, so I'll make this a C12 by 20.7 instead. I'll go ahead and I'll double click on this cone and I'll force it to give me 3 rows instead of 2. And then this channel perhaps simply needs to move over. So I'll just use my normal move commands, and I'll tell it that it needs to move 6.5 inches over. So this is a relatively minor change, but this is the kind of thing that happens all the time in the industry. So if I go back to my drawing list and I want to take a look again at that beam, if I double click on the icon, the first thing that pops up is a warning. Tekla will not let me open this drawing until my numbering has been checked or my piece marks are up to date. So this is a safety to make sure that my drawings are never going to be out of sync with the model. It's simply impossible to do. So if I take a look at my numbering settings, it's important to take note of this because at different stages of the project, piece marks need to be handled differently. If it's the first round of piece marking, then I would use initial numbering. If I'm just about to create my drawings for the first time, I have a setting for that. I also have a setting for after creating drawings, so maybe you've got things back from approval, you have a design change like I just showed you, or maybe after checking. The idea is that you don't lose your piece marks, or that it will try to maintain the same piece marks so that you keep your work. You also have an after issuing drawings for fab, so if something happens where a part's starting to be fabricated, you don't want to have the shop pull a drawing so that you can reissue it with an extra quantity. Maybe you just want that part to take a new mark. So we have these out of the box so that you can use the right settings for the right time in your project. So I'll say after creating drawings, and then I'll go ahead and I will number my model. Now you can see how the drawing list immediately reflects any part that was affected by that change. It's flagged with an exclamation point and it's marked as parts modified. So you may see some other types of notes such as quantity increased or quantity decreased. So you can always get a quick idea of what's going on right here from the drawing list. Perhaps this is a good idea, depending on what time in the project I'm at, to add a revision. So I'll go ahead and I'll highlight those sheets and I'll say, let's go ahead and add a revision 1. Say it was created by me, created on this date, and I'll say that the AC unit was revised. So now in my drawing list I can see the current revision status of any of those sheets. So now if I go ahead and try to open this drawing, Tekla will allow me to open it, and let's take a look at how we handled those changes. So the first thing I want to point out is how that none of the work that we did was lost. We have our text, we have our typical detail, I have my breakout of that plate. You can also see how that the dimensions were flagged due to the change, not just the system created dimensions, but also my dimensions. So my dimensions are no different than the ones that Tekla had created for me automatically. They're handled in the same fashion. I can see how a new section C was cut. My bill of material has been updated automatically. And that new section C was created down here. Now it didn't know quite where to put it on this sheet, so I'll go ahead and I'll just move these views around. And I'll find a space for it. So you can see how Tekla handles those types of changes very, very well, where you're not going to lose any of the work that you've already done, so you don't have to re-clean up, re-scrub, or re-detail your parts. You don't have to keep track of things like your bill of material because Tekla is going to handle that for you. And everything here on the sheet is simply going to reflect what happened in the model. Of course, CNC files can be generated for any of these parts, as long as your numbering is up to date. You can simply select the objects or create from all. Under your File menu, you go to Export, NC Files, and you can choose from options for your different profiles and plates. Now your CNC export is built into Tekla Structures. It's not an additional feature or something that you need to buy. CNC files can be created with a Project Viewer license or any modeling license. So before I end, I just want to cover a couple of brief things. One is that Tekla Structures also has the ability to have different types of project management done in it. Not only is it a great modeling and detailing software, but underneath each part you have these tabs of information we call user-defined attributes or UDAs. So here's where you can come in and track things like who modeled and who checked. You can track RFIs, you can track shop and site status. So if you wanted to track on this part, has it been sent to the galvanizer? Has it been painted? Has it been shipped yet? All of these things can be tracked right here on the parts. Now there are tools that take these user-defined attributes and wrap them up to do other things. One of those we use is called the lotting tool. So if I come under here and click lotting, I already have two trucks set up. Each truck has a capacity of 20 tons. And the idea is that once I have a truck defined, I can go through and start clicking on the objects that I want to include with that shipment. And as you can see, as I pick new parts, you can see the weight left value reducing. So it's keeping track of the weight of the assemblies to help me figure out how many parts I can place on a vehicle. So I'll apply there, and on my second truck I can choose a different group of steel. So this makes sure that you're not going over your weight limit when you're trying to plan what's going out on site. And of course, once you have this information written, we can generate reports. We have an out-of-the-box lotting list that will give you all of the information that you just applied. Another popular tool for planning is called the construction sequencer. This is another extension that you would need to go to the warehouse to download. And what this tool allows you to do is pick the order of erection. So here I click the button and I can simply pick the order that I think my steel should be erected. And Tekla will do two things. One, it provides me with my pick list, and this pick list can be modified through drag and drop. So I can simply rearrange some of the columns to get what I want. I can go to my View tab and play back this erection order in an animation. And then this pick list can be exported to Excel. So this is just a great tool for planning and to visually see how the steel is going to be placed. This and many other extensions and many other tools relating to project management are available in the Tekla warehouse. For more information, or if you want to set up a live demo, come visit us at www.tekla.com/us. Thanks.